Hey students, welcome to Unit 6. So this unit is on all of our quadrilaterals. It's going to be parallelograms, rectangles, rhombuses or rhombi, trapezoids, isosceles trapezoids, kites. Did I leave anything out? Rectangle, oh, square. We left out square. Okay, so this is going to cover all of those shapes that we have, and they're all considered quadrilaterals because they're all four-sided shapes. There's going to be a lot of memorization going on in this unit. So make sure that when you take your notes that you're highlighting things that I tell you to memorize, because it's really important that you start memorizing all of the properties. And the properties do carry over to other shapes for certain shapes. Okay, so starting out with this unit, I have a warm-up question that goes with what we did the last unit or the last day before this unit. So the measure of 5 of the interior angles, remember that formula? Okay, so there's your formula. The measure of 5 of the interior angles of a hexagon, so you need to know how many sides that is, have these angles, and what is the measure of the 6th interior angle? Go ahead and work that out, and that's going to be the first question that you have in your notes. All right, here you go. So we have a hexagon, which has 6 sides. 6 minus 2 is 4. And then 4 times 180 is 720. So we are subtracting all of these from 720, and it leaves you 75. Okay, so now we are going into the notes for the quadrilaterals and starting with parallelograms. Any polygon with 4 sides is called a quadrilateral. However, some quadrilaterals have special properties. These special properties are given their own names. Okay, before we jump into the notes, on your vocab, we have one definition, page 22, just to get knocked out, which is what I'm getting ready to show you here. But you guys know I like you to throw on some color. So a parallelogram is a quadrilateral with both pairs of opposite sides parallel. So this side is parallel to this side, and you have the markings, and this side is parallel to this side, and you have the markings. Different people will write the definition in different terminology, but it's really, really close. Sometimes they will say just opposite sides parallel, and when you hear that, you are assuming that it's both pair. The only time you would ever assume that it's only one pair is if it tells you that it's only one pair. So both pairs of opposite sides are parallel, or just opposite sides are parallel. And that's the only vocab word that we had. Okay, so here's the official notes. A quadrilateral with 2 pairs of parallel sides is a parallelogram. To write the name of a parallelogram, you use this symbol. So you can see that we will be writing parallelogram like this. When we do our proofs, we'll be putting that in the proof as well. And these are what's drawn in the picture. AB is parallel to CD. You can see that we have the markings. And BC is parallel to AD. This is the definition, okay? That is the definition of a parallelogram. Definition of a parallelogram is a quadrilateral with opposite sides parallel, okay? All right. As we go through these properties, okay, I'm going to try to help you to remember how many properties go with a parallelogram. So there are 2 properties. And when I say properties, I'm meaning it is either the definition, a theorem, or a postulate. Okay, we're just going to label all of those as properties. So there's 2 properties that go with the sides of the parallelogram. There are 2 properties that go with the angles of a parallelogram. And there are 2 properties that go with the diagonals of a parallelogram, although we only use one of them pretty much in this set of notes. The other one is from the previous unit, and I'll show you at the end of the notes, at the end of the next page, what I'm talking about with that. So really, it's 2, 2, and 1, but we do have another one that we have already learned that goes with the parallelograms. Okay, let's turn to the next page. So this is going to be, I'm going to label these. Number 1 and number 2 is going to talk about the sides. Number 3 and number 4 are going to talk about the angles. And then number 5 is going to talk about the diagonals. Okay, so this is number 1. And remember, this is the actual definition. If you wanted to highlight that, that is the definition. Okay, so this is number 2, still talking about the sides. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So the way that I would mark that in here is I would put the congruency marks, and I would put the congruency marks like that, and that tells us that opposite sides are congruent. So over here we would say QR is congruent to PS, and we would say QP is congruent to RS. So now we have opposite sides are parallel, opposite sides are congruent. Number 3. Okay, number 3 and number 4 are going to talk about the angles. So if a quadrilateral is a parallelogram, then its opposite angles are congruent. So that means in this picture, angle Q is congruent to angle S. Angle Q is congruent to angle S, and then angle P is congruent to angle R. Technically, we are talking about the measures, so we should put the little m with those. The measure of angle Q is congruent to the measure of angle S. The measure of angle P is congruent to the measure of angle R. The way you guys remember that is if the little congruent, if there's an extra little symbol right here, then there's an extra letter. If there's an extra symbol here, there's an extra marking. So we need to try to keep that straight, but again, I would never count that wrong if you didn't put the M. Okay, so if this angle is 70 degrees, then this angle is 70 degrees. Okay, if this angle is 110, then this angle is 110. Okay, so that's how that goes. All right, number 4 says, oh, by the way, notice these are if-then statements. These are the statements you're going to be putting in your proofs. If parallelogram, then opposite angles congruent. If parallelogram, then opposite sides congruent. Things like that. Okay. All right, number 4. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So this one is often missed. Okay, so you have to make sure you memorize this because we're going to use it a lot. Remember when we had our parallel lines, put little parallel markings on there, cut by a transversal, we had our same side interior angles. So now, because the theorem uses the word consecutive angles, now we're going to start calling them consecutive, just like in the last unit when we learned about the consecutive angles and consecutive vertices, consecutive sides. They go in order around the figure. So these are now not called same side interior. They are called consecutive interior. Okay. That's S, consecutive interior angles. I don't ever really abbreviate those because we're done with those abbreviations and I just want you to call it consecutive interior. You can shorten it, but we don't use CI. It's not something that you'll see written down. So consecutive interior angles are supplementary. If I were to make another parallel line, so now these are parallel, we also have consecutive interior angles going this way. So we have 4 pairs of consecutive interior angles, and you are always going to have a big angle and a little angle. Big angle and a little angle are always going to add to 180. So let's put measure of angle Q plus the measure of angle R. So I'm going this way. Those are going to add to 180. And if it helps you to do a visual, those angles are going to add to 180. Then angle R, the measure of angle R, plus the measure of angle S are going to add to 180. The measure of angle S plus the measure of angle P are going to add to 180. And then the measure of angle P and the measure of angle Q are going to add to 180, so if it helps you to do that as well. Okay, number 5. So this is number 1, number 2, we're talking about sides. Number 3 and number 4, talking about angles. Opposite angles are equal. Consecutive angles are supplementary. Okay, so now we're going to talk about the diagonal. Let's go ahead and grab your straight edge or just draw very neatly. We're going to put these diagonals in here. Okay, so this property number 5 says, if a quadrilateral is a parallelogram, then its diagonals bisect each other. That means they're both cut in half. So let's put a letter T in the middle. That means that PT is congruent to TR. PT is congruent to TR. Those are equal. And then QT is congruent to TS. Okay, take your fingers and measure with your fingers PR, and then keep that measurement, turn your paper. Is that the same? No. So I want you to realize that in our quadrilaterals, there are going to be shapes that have diagonals that are equal to each other, but in this shape, QS is not congruent. QS is not congruent to PR. So remember that, and you can always tell in all of our shapes, you're going to be able to tell by using your fingers and just simply doing a quick measurement. And this measurement will not equal. It's actually way bigger than that other measurement. We'll talk about that a little bit more when we get to rectangles. Okay, so the other one that I left off, which would be number 6, which we really have already learned, so we're not going to include it as our properties, but it's one diagonal makes 2 congruent triangles. One diagonal makes 2 congruent triangles. That was in unit 4. Okay, so that was in unit 4. If you look at just the one triangle, this big triangle here and this big triangle here, because opposite sides are equal, we can show that, and we have a reflexive. So if I'm looking at this big triangle and this big triangle, we have reflexive. So this side is equal to the other triangle. Then we have by side, these 2 triangles are equal. So there's also other side, angle, side, angle. There's other ways we could show, but I just want to show you that these one diagonal will make 2 congruent triangles. We already know that from the last unit. We had pictures like that in the last unit. Okay, turn over. And let's start looking at some problems. Grab your calculator if you don't have it yet. You might need it. Okay, so opposite sides are congruent. Okay, if opposite sides are congruent, then that means A is going to be equal to 12. B is going to be equal to 7. Super easy. Opposite angles are congruent. So X is 112. You can actually write that in if you want. Okay, and then looking on the previous page, using property number 4, what is the value of y? And that's going to be your next question. What is the value of y? Look back at property number 4 to help you. Okay, you should have that consecutive angles are supplementary. So we would subtract from 180 and you would get 180 minus 112 leaves you 68 degrees. So angle y is 68 degrees. This angle up here would also be 68 degrees. Notice they're consecutive interior this way and this way. They add to 180. Any way that you can combine angles, consecutive interior angles, they're going to add to 180. Remember, they are same side interior angles is what we called them before. Okay, number 15. Okay, real easy. I know angle B is 10, or excuse me, segment B is 10. It's very obvious. Okay, we've got a diagonal that has a number on it. So I've got, if this piece is 10 right here, then A, which is representing this segment, has to be 10. Now, guys, pay attention. If they want an angle, they're going to put the little degree symbol. If they want the segment, there's no degree symbol. So this segment A is 10 as well. Okay, and then we are going to have alternate interior angles. So I want you to grab, either make it darker with your pencil or grab a highlighter. You guys are going to have to start seeing these alternate interior angles because these lines are parallel. Then you have alternate interior angles that show up anytime you have these diagonals. So angle X is going to be 62 degrees. And then we have our vertical angles, which is something we already know. So Y is going to be 33 degrees. Guys, this is a big deal. Anytime you see that you have diagonals in here and you have angles, draw that Z. And there's lots of ways I could draw a Z. I could draw the Z this way. Okay, draw the Z with the parallel lines and a transversal, and you're always picking up alternate interior angles everywhere. All right, number 16. Okay, let's see. We've got A is 20. Easy. B, so I've got 2B equals 28. You don't have to show the work on something that's simple. B is 14. That's easy. Okay, and then X. Okay, so I don't think we're going to be able to find the X just yet. I think we're going to have to find the Y. Actually, we could find the X first. If I had these two angles combined together, 70 plus 42 is 112. Okay, these are consecutive. By the way, I had that 112 up here, didn't I? Yeah, so that means this angle here has to be 68. So we can make an algebra equation, 4x equals 68. Okay, 4x equals 68, divide, you get x equals 17. So we can find that first. All right, and then to find y, based on what I showed you here, and that's your next question, would you please find the value of y by using your alternate interior angles? Okay, my alternate interior angles are here. So 42 equals 3y. And if you divide, you get y equals 14. Okay, next question. So first, I'm going to go ahead and ask you a question. And my question is going to be, what equation will you set up to find x? Okay, what equation? Okay, what equation will be used to find x? Okay, the correct equation is that these are your consecutive interior. They are going to add to 180. This is the correct answer to the question that you already know. And these are going to add to 180. So if you go ahead and do that, you get x equals 31, which I feel like you guys already know how to do. So go ahead and just write that answer down. And then to get y, remember opposite angles are congruent. So 3y equals 123, and y would equal 41. So you see how in these pictures, we're going to use all of the properties, and you just have to know the properties. You have to know the properties. You have to know the properties. There are 5 properties. If you came in and I asked you, write down all 5 properties, can you do that? Remember, there's 2 for the sides, 2 for the angles, 1 for the diagonal. Really 2, but we say that there's 1. Okay. Okay, number 18. So this has just measurements. So to find x, this is a diagonal. The diagonals are bisected. So this piece is equal to this piece. 2x equals x plus 9. That's easy, just x equals 9. And then opposite sides are congruent, so these pieces are equal. 3y minus 9 equals y plus 12. 2y equals 21, I believe, and it is perfectly fine in geometry to get decimals, so don't stress out about that. So y is 10.5. Okay, last question for this page. So let's look at the x's first. For the x's, these are your alternate interior angles again. So 3x equals 45 and x equals 15. And then for your y, these pieces are equal, so go ahead and find y, easy answer. Okay, go ahead and find the value of y. Okay, you should have set those equal to each other and you should have got y equals 7. Okay, flip over to the next page. All right, so let's look at this picture here. So in the accompanying diagram of parallelogram ABCD, side AD is extended through D to E, and DB is a diagonal. If the measure of angle EDC is 65, EDC, and the measure of angle CBD right here is 85, then find the measure of angle CDB. So I want to know what this angle is here. Because it's actually a really easy question, because all I have to do guys, remember, you have to be told this in order to do this, okay? So that means this angle is 85. And so then these three are making a straight line. And so you take 180, subtract 65, subtract 85, and it leaves you 30. Okay, so the measure of angle CDB is 30 degrees. Now let's take this one step further. And I'm going to ask you this as one of your questions, so you're going to have to really put some thought into it. What is the measure of angle A? Okay, so go ahead and do some figuring and give me an answer. Okay, here you go. The answer is 65. There are several ways that you can get this. First of all, if I were to put the 30 here, I could do that because these are alternate interior angles as well. I could draw the Z this way. And I know that this big angle here, 85 plus 30 is 115. And then I know this big angle and angle A are consecutive interior, so they add to 180. So 180 minus 115 leaves us 65. So this angle has to be 65 degrees. This angle would be 65 degrees as well. Okay, remember, consecutive angles are supplementary, opposite angles are congruent. You've got to know that. Okay, here's a question for you. Use a different color. Do you remember the name for this angle here and this angle here? Okay, I have two parallel lines. I have a transversal, and I have these two angles here. So my question to you is the name of the 65-degree angles that I have marked. Okay, go ahead and give me that answer. Okay, so don't forget, we do have corresponding angles. If they ever extend an angle, it is going to make corresponding angles. These angles are sitting on the parallel lines, and the transversal, they're on the same side of the transversal. One's on the exterior, one's on the interior. Okay, so when we have parallelograms, we mostly have alternate interior and consecutive interior. Okay, alternate interiors when we can draw the Z, consecutive interiors, these two angles that are in order. And so now I want you to know that when we extend a side, we can have corresponding angles. So go ahead and pause your video, draw this picture. Okay, so this one you may have had trouble labeling and you don't know where to put the letters. When I started labeling it, I went LMNO, and I went, well, the outside angle has to be 72, and that's a big angle. So I moved them all around, and I put the O over here so that my exterior angle would look 72 degrees. It really doesn't matter as long as you go by the shape and you know what you're doing. The easy question is, what is angle L? And I just wanted to show you it's exactly what we did up here, that angle L is 72 because it is it's corresponding. All right, it is corresponding angles. These are your parallel lines, and those are your corresponding angles. You could easily get the answer by saying this angle would be 108 because these make a linear pair, 180, and then these are consecutive as well. So you could actually do a proof to show This is a linear pair, and then you could do, you also have alternate interior here because this would be 72. You can see the Z this way. All right, so all these visuals you need to be paying attention to, that you do have congruent angles as corresponding angles. Okay, let's do a proof. These proofs are not going to be too difficult for you. They're going to involve a lot of things that we have covered before. So let's go through and start working on this proof. Okay, so for this one, we've got that we have a parallelogram, the big shape. So we are going to be using some of the properties of the parallelogram. You can see that we have triangles in here. So we're probably going to be using side, angle, 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 side, things like that to show triangles are equal. And then we'll be showing CPCTC to show that we have parts that are equal. Okay, you will be using segment addition postulates, angle addition postulates, substitution, subtraction, things like that we've already learned that you guys should have down, and you should be able to write these proofs using the things that we've learned already. Okay, so I'm going to go ahead and pause the video and get my given written down. Okay, so I wrote it like this. ABCD is a parallelogram. Angle GHA, which I have labeled as 1, and FEC, which I have labeled as 2. Do you guys know that you can do that anytime? You can put numbers into your proof and use those numbers down here, but if they're not shown in the picture, you can't write them down here. So I have those in my picture. I'm going to use angle 1 and angle 2 instead of those two angles. And then I have HB is congruent to DE. So anything in my picture is what I have from my given. We are trying to show that these two pieces are equal, and we're going to do that by CPCTC. So what I need to do is to show this triangle is congruent to this triangle. Okay, so first thing I'm going to do also is I'm going to put a 3 here and a 4 here. Because I know I'm going to use that, I can have those alternate interior angles. Okay, so I'm going to have those alternate interior angles, and I'm going to be using that in my proof. Okay, so I know I've got this from my given. Those are equal. Okay, so I'm going to go ahead and say angle 3 is congruent to angle 4. Okay, angle 3 is congruent to angle 4. And those are alternate interior angles. Let's go ahead and put some marks on them. And so remember what we write: if lines parallel, then alternate alternate interior angles are congruent. Okay, so guys, look what we have. We already have two angles. So my options are: can I get angle, side, angle? Angle, side, angle. Can I get angle, angle, side? No, because that's what we're trying to prove. So I can't use that. Angle, angle, side. I do not know anything about this diagonal. So I actually could put that this is equal to itself and subtract it out, but we're not going to do that. I would rather use these two pieces here. Okay, so let's get a segment. Oh, actually, before we do that, let's go ahead and say DC is congruent to AB. And I'll show you how to write that because I haven't shown you yet. So we're going to say this big segment here is congruent to this big segment here. DC is congruent to AB. Okay, so what is happening is we have a parallelogram and we have opposite sides congruent. So we're going to say if, and you're going to draw that parallelogram. If you have a parallelogram, then opposite sides congruent. So you're using the properties 1 through 5 that I gave you in your proofs, and you're going to write them: if parallelogram, then opposite sides are congruent. If parallelogram, opposite sides are parallel. If parallelogram, diagonals bisect each other. If parallelogram, and you can write any of those statements because I've taught them to you already, so now we can use them in the proofs. Okay, now give me your segment addition postulate. So I'm going to use the top one first. DE plus EC equals DC, comma, AH plus HB equals AB. And that is segment addition postulate. Segment addition postulate. Guys, I want you to understand, when you have segment pieces, you are probably going to use segment addition postulate. When you have little angle pieces, like if I were talking about these two angles here, you're probably going to use angle addition postulate. But you have to follow these steps. I cannot say that these two are equal, or excuse me, I can't say these two pieces are equal until I show these two pieces are equal in the proof. It has to be there first. That's why I wrote it down first, because now that I have these two pieces equal to each other, I can say by substitution, and guys, it's not transitive, it's substitution. Transitive is when these are exactly the same, like 180 and 180, that's when it's transitive. But these are different. This is just substitution. So now I can say these two pieces are equal to each other by substitution. There's a few people in class who are missing that step. You have to show the pieces are equal before you put all of these equal to each other. All right, so now we are going to be able to put these two pieces equal to each other. Substitution. Okay, let's use this piece here because HB is equal to DE. HB is equal to DE. We're going to subtract those out. So EC equals AH. Subtraction. Okay, let's go mark this in our picture. EC equals AH. AH is equal to EC. So you guys go ahead and, just kind of get that in your mind, because when we have little pieces of segments, you're going to be doing all of those steps. Okay, now look at my picture. Look at my little triangles. I've got angle, side, angle, angle, side, angle. So now we can say triangle, if I'm going to label this one AGH, and I can name that angle, that triangle any way I want, AHG, HAG, GHA, it doesn't matter. This one has to match up. That's what we learned in Unit 4. So AGH, AGH, I went big yellow, pink. So I'm going to say CFE, big yellow, pink. Okay, triangle CFE. And that is by angle, side, angle. And then I'm able to say that GH is congruent to EF, CP, CTC. Everything in that proof except for this step right here, you should know, okay? This step right here is the only new piece. So see, guys, how important it is to always stay caught up with geometry. Once you get behind, you're always going to be behind. You have to know the things that we've learned in the previous units to help you with what we're doing. Okay, flip over. I want to change this proof, so I want you to take this out. And I want you to put PX equals 8 and YA equals 8. Okay, so I'm going to pause the video. I'm going to get my given written down. Okay, so here's the plan. I've got in pink what we're trying to prove. So notice this is not in these triangles. So what I need to do is to show that these two triangles congruent by one of our 5 methods. It's not going to be hypotenuse leg, people. Okay, so one of the other, it's not going to be side, 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 because I don't know anything about this piece in here. But I am going to be using segment addition postulate. I am going to be using subtraction. But in order to do that, I somehow have to get these two pieces equal to each other. Okay. And so that we'll be able to subtract and we'll be able to get these two pieces equal to each other at the end. So remember, it's not wrong to put in things that we don't need. Okay. You want to try to avoid that. But I do know that I have a parallelogram. I do know that I have opposite sides equal to each other. So I'm going to go ahead and put that in the next step. I'm going to say SP is congruent to RQ. And then I'm going to say SR is congruent to PQ. My reason is going to be if parallelogram, and if you want to write out the word parallelogram, you can. Okay, if parallelogram, then opposite sides congruent. Okay, so I can go ahead and put that in my picture now. Remember, once you write it down, you can mark it in your picture. I know that SP is congruent to RQ. I'm not going to mark the big side because I'm going to end up doing that subtraction, so it's not that big of a deal. I do know that these two angles are equal because they're opposite angles. Okay, so let's go ahead and put, I also know that these angles are equal, but I don't think I'm going to use that. Okay, I don't think I'm going to use that. Okay, so let's go ahead and put angle P equals angle R. Really should be congruent. Really should be measure of angle P is congruent to the measure of angle R, and then by definition of congruence, we take that away, but we're just going to leave it like this. Okay, so this is going to be if parallelogram, then opposite angles are congruent. Okay. All right, so now I've got those congruent. Okay, the PX and the YR are coming from here. So we can go ahead and Y, that should be an R. I'm so sorry. That is an R. There we go. Make an R look like an A. All right, so we're going to go ahead and say that PX is equal to YR. And that is transitive. Really, POE, but if you don't put that on there, it's okay. All right, so now we've got these two. Can you see now that we have congruent triangles by side, angle, side? Okay, so I'm going to say triangle SPX is congruent to triangle SPX. If I say SPX, then this is going to be QRY by side, angle, side. Okay, and then now since I've got you know what, I don't even need that. I was thinking of something different. Let me look at this. So I showed these triangles are congruent, but I'm not going to use a CPCTC, so I actually didn't have to do that. All I needed was to get those pieces equal to each other. What if I was realizing that we didn't have to do any of this because I changed this proof because this was a little hard for you guys right now and I didn't want to do those. And I changed it. And now I realize that what I changed it to is you guys didn't even have to do any of this. So let me change it to something else. Let's change this. Don't you love it that I'm in charge and I get to change it to whatever I want to? And let's just change it to SX is congruent to QY. That is something that we would need the triangles for. So we're changing this to SX equals QY, which means we are trying to show these two pieces congruent. Now that's really well, you know what? If I did that, then I wouldn't even need to show this piece down here is equal. Well, let's just go ahead. Don't y'all love me? and prove I'm just going to do all this. I'm just going to give you guys a lot of instruction. Let's prove that this is a parallelogram. Ha, this is going to be a great proof. All right, so now let's get this piece here. Okay, let's get this piece here. So we are going to do the segment addition postulate. We have shown that these pieces are equal already, so we can do the segment addition postulate to show that these two pieces are equal. All right, so segment addition postulate is going to be px plus xq equals pq, and then ry plus ys equals rs. Okay, so now I've shown the segment addition postulate. Now I can subtract these two pieces because they're equal, and that's going to leave these two equal. So because PQ is equal to RS, right here, we are able to put these equal. And then because these are equal, PX is here, RY is here, we are now able to show XQ is equal to YS. And so this was substitution, and this was subtraction. So we have shown these pieces are equal. I can say the orange pieces are equal by CP/CTC. Let's do 9. And say SX is equal to QY. CP/CTC. Okay, and I'm going to do 4 little marks here. Okay, so you guys know what a converse is. So if I take this property number 1 and use the converse, if no, not parallel, sorry, wrong one, this one. If I write the converse, if opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So that is what we're doing in this proof. So number 10 is I'm going to show SYQP. Let's write it this way. SYQP is a parallelogram. And then number 10, we say if quadrilateral has opposite sides congruent, then it's a parallelogram. Okay. If a quadrilateral has opposite sides congruent, then it has to be a parallelogram. Okay. Sorry, I butchered that so much, but it just wasn't working out to what I wanted it to work out to be. And the original proof, it had these two angles equal to each other and these two angles equal to each other, but we were still trying to just prove these pieces equal, and I couldn't logically get that to work out. So I changed it, and then I changed it, and then I changed it again. Okay, we are almost done. All right, down here, here's the recap of what we learned, okay? And this is your last question. Go ahead and answer that question for me. Okay, you should have got that the answer was 1. Nothing up here says that the diagonals are congruent. The only thing about a parallelogram is that the diagonals are bisected. They bisect each other. All right, that's the end of the notes, and we will do the worksheet in class together. Thanks, students.